potential energy. Now what this potential energy means? You are knowing that if there are two like charges, plus Q plus Q0, then there will be a force of repulsion. Out of that, if any one is opposite in nature, that is one charge is positive, another charge is negative, then there will be a force of attraction. Means if any one charge Q is present in the medium at any point O, and in that same medium if another charge is present as a Q0, and if I want to bring this Q0 charge nearer to Q, so during that process to move this Q0 charge towards charge Q, some amount of work is done, and this amount of work done is nothing but the change in potential energy. So what we can say that work done to move any one charge in the presence of another charge, we have to do certain work, and that work done is nothing but the change in potential energy. So that change in potential energy I can say as a du, as a change in potential energy, must be equal to nothing but as a work done, which is equal to dw. That dw is nothing but as a f minus f, vector minus f into dot vector dr. This minus sign indicate that there will be a negative sign, indicate that direction of force and direction of displacement, they are opposite to each other. Now for that consideration, for this expression of potential energy, we can consider a derivation. In that derivation, what I will say, let's consider there is a point O, and at that point O there is a source charge capital Q, and from this source charge capital Q there is a point. At this a point there is a Q0 charge which is also positive. This Q0 charge will be at a distance of R1 from the test charge, and there is another as a B point. This B point will be at a distance of R2. Now if I want to bring this Q0 charge from A to B through a displacement as a dr, so during that process there is a change in potential energy, because work is done to move the charge from A point to B point. So work is done to move the charge from A point to B point through a distance of R2 to R1. So now there will be a certain change in potential energy. So that change in potential energy I can say as a du, or I can say as a delta u also. So now what I will say, delta u is equal to minus f into dr. What this f is there? F is nothing but the Coulombs force. Now that Coulomb force is in between what? Test charge Q0 and source charge Q. So according to Coulomb's law I can write down force is equal to nothing but minus 1 upon 4 pi epsilon naught into Q0 upon R square into dr. This dr is nothing but the displacement vector. So here vector f, therefore I have written here dr. Dr is nothing but the vector displacement. So what it indicates? Direction of force and direction of dr. Dr means displacement towards the plus q charge will be opposite. So this negative sign indicates the significance of that opposite sign, opposite direction. So now what I'll write down? du. This change in potential energy can be written as, now this is f and here is your dr. So what I'll say here, which is nothing but, I can call it as, it is equal to nothing but integration. Why I am going to put the integration? Integration will be put because there is a distance limits. So distance limits are nothing but from R2 to R1 minus 1 upon 4 pi epsilon naught capital Q Q0 upon R square into dr. So now this 1 upon 4 pi epsilon Q Q0, these are the constant quantity, so that should be taken out of integration. So I can again write integration R2 to R1, or sorry, Before that, I'll take the constant quantity out of integration. 1 upon 4 pi epsilon naught capital Q Q0. These are the constant quantity. Integrations are from R2 to R1, and here is 1 upon R square into dr. Now we have to integrate this 1 upon R square. This 1 upon R square is also written as R raised to minus 2. And now you have to see the integration of this term. So in 11th standard you have seen the rule of integration. In that rule of integration, what we have to concentrate? We have to concentrate on the power of variable. Your variable distance is R. Power is minus 2. So in the minus 2 power, we are going to add 1. So minus 2 plus 1, that is minus 1. And it is divided by total power. So total power is nothing but minus 1. Means now I can write down here as a potential energy, change in potential energy can be written as minus 1 upon 4 pi epsilon naught capital Q Q0. Then I can say that integration can be written as R raised to minus 1, and their limits are nothing but R2 to R1 with division minus 1. Now this minus 1 and this minus sign, that will become plus. So now I can write down the next step as a change in potential energy delta U can be written as minus minus will become plus. So 1 upon 4 pi epsilon naught capital Q Q0 into bracket R raised to minus 1. Instead of that, I can write down 1 upon R. Limits are nothing but from R2 to R1. Now I have to put the limits. While substituting limit in the place of variable, I can first put upper limit minus lower limit. So your equation will become 1 upon 4 pi epsilon naught capital Q Q0 into bracket. I can write down 1 upon R1 minus 1 upon R2. So this is nothing but the change in potential energy when your Q0 charge will get displaced from A point to B point. Now here, this work, change in potential energy is nothing but the work done. So I can write down, instead of change in potential energy, this is to be called as a work done. Now here, if R1 and R2 distances, instead of that, if I am saying that your test charge Q0 will be at a distance of infinity, means now if I say that if your R2 distance will become infinity and your R1 distance will become R. So at that time your change in potential energy equation will change, and that change in potential energy equation will become as 1 upon 4 pi epsilon naught capital Q Q0 into bracket. Here I can say that instead of R1, 1 upon R minus 1 upon infinity. But 1 upon infinity is nothing but 0. So if it is 0, means this term will get cancelled, and I am getting change in potential energy is equal to nothing but 1 upon 4 pi epsilon naught Q Q0 into 1 upon R. But this change in potential energy is nothing but work done in bringing the charge from A point to B point. So this change in potential energy will be also written as work done in bringing Q0 charge from A point to B point, can be written as 1 upon 4 pi epsilon naught Q Q0 upon R. Now here so many modification formulas are there. That is, instead of test charge as a Q0, if Q0 charge will be replaced by Q1 and your source charge Q is replaced by Q2. So now your formula will get modified. That is, while bringing Q1 charge from A point to B point, change in potential energy, which is nothing but work done in bringing Q1 charge from A point to B point. So work from A to B can be written as 1 upon 4 pi epsilon naught. Instead of Q and Q0, I can write down Q1, Q2 upon R. And this is nothing but as our change in potential energy. So this change in potential energy is also called as a work done in bringing charge in the field nearer to another charge as a source charge. So this is about your potential energy.